Hello, everybody, and welcome back to Unit 7 of Regents Chemistry, where we'll be talking about chemical bonding. So, today we are going to be talking about the intermolecular forces. Up until this point, we have been talking about the intramolecular forces, which were all the three different types of bonds that we talked about: ionic, covalent, and metallic. Intramolecular forces are basically the attractions between the atoms in a molecule. So, for example, let's say here we have a water molecule. The intramolecular forces or the bonds are basically those attractions between oxygen and hydrogens within the water molecule. Intermolecular forces are basically the attractions between two, three, four, or whatever different molecules. For example, let's say here we have one hydrogen molecule, here we have another hydrogen molecule. Now, both of them are going to have some sort of attraction. If they are closer to each other, they are going to have some sort of attraction to each other. And those forces are what we call the intermolecular forces. Now, of course, they are not as strong as the bonds or as the intramolecular forces. However, they are strong enough that we can't really ignore them. So we have to talk about them. So let's see what are some of the intermolecular forces that we have out there. The first type of intermolecular forces are called the dispersion forces. Now these are the weakest of all types of intermolecular forces, but they are also the most common. And they are most common because they are the weakest, so they can just like make and break anytime. So basically, they are caused by the motion of electrons. So the more the electrons an element has or a molecule has, the more dispersion forces it has. Um, so basically, let's say we are looking at halogens, which are in group 7A. Now, as we go down that group, we start with a gas, with a fluorine gas, and then we keep going down uh, to, let's say, bromine. Bromine is now a liquid. Then we keep going down, and then iodine is now a solid. So basically, what happens here is that all of them are making non-polar bonds. Like they have the same type of bond because fluorine and fluorine, remember, it's the same element, so they don't have any electronegativity difference. So they are going to make non-polar covalent bonds when they share their electrons. However, because as we go down the group, we are increasing the number of electrons, that's why they are coming more and more together, and that's why they have like more and more van der Waals or dispersion forces. All right, next up we have the dipole interactions, which normally occur in, you guys might have guessed it from the pole, they normally occur in polar molecules, and they occur when the opposite ends or the opposite poles are attracted to each other. So like the partially positive part is attracted towards the partially negative part of another molecule. So they are slightly stronger than the dispersion forces. Um, and however, the thing to keep in mind is that even though the opposites are attracting just like they do in ionic bonds, where we have a positive ion and a negative ion, both of them attract each other, electron from one moves to the other. That is not the case here because these are like not as strong as the ionic bonds. Yes, the opposites are attracting, but still they are weak intermolecular forces and it's very easy for them to break. So for example, here we have a hydrogen fluoride molecule, which has a partially positive and a partially negative end, which means hydrogen, which is partially positive, is less electronegative. Fluorine, which is partially negative, is more electronegative. Um, and then here we have another hydrogen fluoride molecule. So now the partially negative part, the fluorine of the first hydrogen fluoride molecule is going to be attracted towards the partially positive part or the hydrogen of the other molecule. Here's what it looks like when we have more than two molecules together. So here we have a whole bunch of those molecules. All of them have partially positive and partially negative ends, which means they have two different dipoles, and each dipole is facing those or it's feeling those attractions towards the oppositely charged pole of other molecules. Alrighty, next up we have hydrogen bonding, which is very specific. Very specifically, these are the forces of attraction when we have a hydrogen bonded to a nitrogen, oxygen, fluorine, and chlorine only. Nothing else. Only these four elements. And that's because all four of them are very, very, very electronegative. Hydrogen, not so much. So basically, when hydrogen is attracted towards these four elements, it's a very strong dipole. So dipole means we have one end that is very partially positive, the other end that is very partially negative. So these four elements will be partially negative, hydrogen will be partially positive. And so hydrogen is also like partially kind of attracted towards the lone pair that any of these four elements have. As they're bonded to other things. And this type of intermolecular force is basically the strongest intermolecular force out there. So here we have an example of a hydrogen bond between two water molecules. So if you guys see this partially positive hydrogen on one of the water molecules is being attracted towards the partially negative oxygen, and specifically the lone pairs on that oxygen in the other water molecule. And then here we have like a whole lattice of a whole bunch of water molecules that are hydrogen bonded to each other. Finally, we'll be talking about the molecular ion attraction, which is basically a force of attraction between the charged end of a molecule. So a charged end means a partially positive or partially negative end of a molecule, and an actual ion of the opposite charge. So this will be, let's say, an attraction between a negative ion and a partially positive end of a molecule, or a positive ion and a partially negative end of a molecule. So for example, when you dissolve salt in water, so here's like a quick picture of that. Let's say we are dissolving table salt, sodium chloride in water. You guys see all those pretty water molecules in there, H2O. Now when sodium chloride dissolves in water, it breaks down into the sodium ion and the chlorine ion. Now the partially positive sodium ion, as you guys can see, is attracted towards the negatively charged part or negatively charged portion of the water molecule, which is oxygen. And then the negatively charged chlorine ion is attracted towards the partial positively charged hydrogen ends of the molecule. So this is what we call a molecule ion attraction. Now, very, 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 very important thing to remember. Why are some chemicals gases, some are liquids, some are solids? That's because of the types of intramolecular forces that they have between them. IMF is just a strong for short form or abbreviation for writing intermolecular forces, so do not ever get confused with that. And remember, gases have weaker intermolecular forces because just think about what gases look like. Their molecules or their particles are super, super far apart. They're all over the place, so they're not together enough to have a lot of intermolecular forces. That's not the case with solids because solid molecules are packed together in one form, and that is why, and that's because their molecules do have a lot of intermolecular forces. Now, these forces have a very strong effect on a lot of properties, like the viscosity of something. So viscosity is how thick something, a liquid is. On the solubility, how well we can dissolve something in water or whatever liquid we have. The melting point, the boiling point, the temperatures at which something starts to melt or something starts to boil. The surface tension, which means how well can something stand on the surface of any liquid, and then the chemical reactivity. But out of all of those properties right now, the most important one that you guys should remember is the effect of intermolecular forces on the melting point and the boiling point. Both of them have a direct relationship with the intermolecular forces, which means the stronger the forces in a substance, the higher the melting and the boiling point is. Because if the forces are very strong, it's hard for that thing to start melting or to start boiling, so it's going to need more and more temperature and it's going to take a longer time. So the stronger the intermolecular forces, the higher the melting and the boiling point. Always remember that. Alrighty guys, that's it for now. Happy learning, take care, and I'll see you all next time.